Hi, I'm Art Wall. I'm Director of Fab Operations, and today we're going to take you on a virtual tour of our fab facility here at NextFlex.
The NextFlex Fab facility, located in San Jose, California, is approximately 10,000 square feet of floor space and is separated into three main process areas: printing, assembly, and test. We'll begin in the printing area of the fab. First, let's take a look at the multifunction FHE tool from NScript. This system features 6 different capabilities, 2 of which are extrusion printers that are unique because they are insensitive to the viscosity of the ink. In addition, there is UV curing, pick and place, micro machining, and 3D printing, all on this one tool, making it extremely versatile. The next printer is the Komori, an offset gravure for fine feature printing. This machine is particularly special because of its ability to print very high resolution on a full sheet at a time. The Komori Corporation has even demonstrated printing silver traces down to 5 microns, so very fine lines.
There's a lot of moving pieces here. There's a lot of things that go on to make flexible hybrid electronics. But really, most of it falls into 2 pieces. We make the circuit, but we make it in a very different way. We do it by printing, so it's all additive technology. And then we add the components by doing pick and place. And we do things, for example, with thin die. So we'll take wafers of high-tech silicon wafers, thin them down to where the whole silicon itself becomes flexible, and directly attach those to those circuits.
The last printer we're presenting is the screen printer. It's from HMI and is the workhorse of the fab. Screen printing is widely used because it's inexpensive and very fast. We can print a new sheet in less than 30 seconds.
In a field like this, you're trying to push the boundaries of the possible. So in order to become more flexible, you have to go thinner with most of the materials to make them flexible. Like silicon is normally a rigid crystal, but if you thin it down far enough, it starts to become flexible at about below 100 micron thickness. It'll start to become flexible.
The fab has 2 great confocal microscopes. The first is from Keyence, a laser confocal microscope with very high resolution. The microscope can see down to nanometer scale features and utilizes easy-to-use and powerful software to analyze a surface in 3 dimensions. Now let's take a look at the assembly lab. In this area, we have the Besi Datacon 2200 EVO. This is a true manufacturing die bonder. It is specifically designed to handle very thin die. The Besi is one of the more complex tools in the fab, but it's a very versatile and powerful machine. It ejects the die from the wafer, picks it up, then flips it over, enabling it to do flip chip attach. If needed, it has the capability of dispensing a special kind of adhesive to attach those chips. The machine grabs the chip and pushes it into the adhesive, then heats it from the backside to cure. All of this is done in this very small compact machine. The next is the FANUC robot. The robot was originally purchased to do automated programming shown here, but we've expanded its duties to include adhesive dispensing, component pick and place, and visual recognition. Parts can be scattered around, and the robot then uses the vision system to identify exactly which parts they are. It picks them up and places them in special packages. In the test lab, we have 3 different units on loan to NextFlex through UASA. With these devices, electrical components can be bent and stretched while being tested.
We need this mix of tools that have elements of established technologies, more kind of difficult and kind of exploratory technologies, all the way to, let's just say, visionary technologies. So it's that mix that is critical, I think, to advanced electronics, and we need the established technologies so we can serve companies with processes that we know how to operate, and we typically add to them things that print on curved surfaces or use extremely thin chips, which is again a new technology that's coming about. Once you bring that technology into the conventional mix, you created something that can become very different.
Another piece of equipment in the fab is something very new that is in the process of development. This is the Stoibli 6 Access robot that has been integrated with a high-resolution Keyence camera and vision system. This is only the beginning of what the machine is going to be able to do. The machine will evolve as we work with it to print, dispense, assemble circuits, and more.
There's some really cool and innovative things happening here at NextFlex relative to automation and equipment. Some of them aren't even here yet. One of the other neat things about coming to NextFlex, every time you come, you'll see something different. We're working on some very innovative automation methodologies for flexible hybrid electronics.